Generalized Linear Models with Examples in R, Chapter 3, and we're on question 3.12. Okay, so we're going to look at a data set called ruminant. Okay, there's a table in the book that has the data, but that data is really just the ruminant data file, so I won't reproduce it here. And then we're meant to go and do some things with that data set. Okay, so this data set is apparently describing the digestible energy content of different types of food and the percentage of dry matter in that food and the percentage of energy that's digestible in that food. Not really sure what any of that means, but it's okay. So first thing we want to do is to install the GLM's data package and load it. And then I'm grabbing the data ruminant, and then I'm just calling it D. Okay, and it looks something like this. It's the first 6 rows of many rows, I guess. So, okay. So now the next thing that we want to do is to, let me clear some of these answers just so it's get more stuff on the screen, and we'll load it up later. So the next thing that we want to do is to plot digestible energy content. So I guess that's this variable against the other 2 variables and then comment on the relationships. Okay, so I'm going to do this in a couple of ways. So first I'm going to plot energy digest against dry matter digest. And then I'm going to plot energy digest against energy. Now in both cases, I'm going to adjust the size of the little markers of the data points according to the size of that 3rd variable. So in this first one where I'm plotting energy digest against dry matter digest, I'm going to make the size of the markers correspond to the amount of energy. Okay, and then similarly for the other plot where I'm regressing or plotting energy digest against energy, I will make the size of the markers correspond to the size of dry matter digest. And in both cases, the way that I'm doing this is I'm just normalizing the variable. So I'm taking the value of that variable minus the mean divided by the standard deviation, just a way of standardizing it. And this made very small markers, and so I added 3 and then multiplied by 3. But that was just to kind of magnify everything. Okay. And I will also use the pairs function, which will plot each variable against each other variable as both x and y axes. Okay. So we'll pull those plots out here. Okay, so here we have our plot. So here's the first plot. So energy digest against dry matter digest. Okay, so you see a fairly linear relationship between the 2 variables, and then not only that, but look at the size of these markers. Okay, they generally correspond to, as we move up and to the right, the markers get bigger. I mean, it's not a perfect match, but pretty darn close. Okay. And then here's the second plot where now it's energy digest against energy, and we see a very similar thing, right? We see kind of this a very linear trend, and more or less the markers are, the size of the markers is following that trend. And then we can also look at the pairs plot here. So the way that you read this is let's take this one for example. Okay, so this plot has energy digest as the y-axis and dry matter digest as the x-axis. Okay, so if we wanted to locate this top plot here, we would want to go where dry matter digest was the x-axis and energy digest was the y-axis. Okay, that's what we have right here. And if we wanted to find, the corresponding of these bottom plots, we would find where energy is the x-axis, so that's here. So these 2 plots above it are the energy is the x-axis, and energy digest is the y-axis. So that would be that plot right there. Okay. Now, because they're so highly correlated, these plots look very, very similar. But okay, if there wasn't so much correlation, these plots would be much more discernible from one another. All right. So now in in part 2, we're supposed to compute the correlations among the 3 variables. And so the easiest way to do this is just to use this core function. So I'm using the correlation of the variables among D, and I'm just rounding it to 2 decimal points, just so it's easier to look at. And we see very high correlations. Okay, so yeah, which is exactly what we saw over here in our plots. So that's not surprising. Okay, so now we're supposed to find a suitable linear regression model. Okay, so again, what does suitable mean here? I mean, I guess that really depends on kind of what your hypothesis is, but so I just have two models here. I have an additive model and then one with an interaction term that I'm calling mx, and we can plot these, or I'm sorry, not plot these, but run these models, and we get what we get. The question is not really worried about these results, and so I won't discuss them here. What it's worried about is to perform a diagnostic analysis, and in particular, one observation is different from the others. Does the observation have large leverage, or I'm sorry, large residual, or a large leverage or high leverage? Okay, so I have both of my models. Okay, and so I'm just using the plot function, which gives you these nice plots here. And if we look at both of these, in fact, I'll just look at one, but the trend is the same in both of them. Let's hopefully zoom in here. Okay, so there is one weird observation here, and it's observation 1. Okay, our program took the liberty of finding kind of this weird one and labeling it 1 for us, and so that's nice. Otherwise, it can be a little bit of a hassle if it doesn't label these things. So we see that it has a fairly large residual. Okay, but we want to know, does it have a large residual or a large leverage? And we see that it has actually both. Okay, so it has a large residual, which you see on this y-axis here. It's like 3 standard deviations away, and it has the largest leverage of any other point here. All right, so I guess that's the answer. But I wanted to also plot this, and just to identify on our plots, and it's way down here. Okay, it has it's very low in all 3 of these variables. And so it's so small, in fact, that when we plotted these and adjusted the size of the markers according to the third variable here, it was so small that it doesn't actually even register on here, right? That's why I had to actually pull it out with this red X here. So, okay, that is it.